Today I'm going to be making a video for the AP Computer Science class on its unit on iteration. So let's go take a look at what we're going to be doing here. So in the AP curriculum, this unit is described as follows. So iteration, or essentially what we in my course would call loops, has previously been covered not only in the Computer Science 20th course as an entire unit, but also in the introductory unit of the Computer Science 30S course. Iteration uses both the while and the for loop, combined with Boolean expressions being one of the main components in iteration, and several standard algorithms that use iteration as part of the process. Iteration obviously will be used with things like traveling data structures like arrays or array lists or even two-dimensional arrays. And it's a necessary component in many standard algorithms such as search algorithms and sorting algorithms covered in later parts of the AP curriculum. Here is a snapshot from the AP curriculum. So you can see it's section 4.1 down to 4.5, the while loop, the for loop, developing algorithms using strings, nested iteration, and informal code analysis. It deals with the big idea of control. Iteration is another control structure. All right, in terms of weighting for the AP exam, believe it or not, iteration is the heaviest weighted section. So it's from 17.5% to 22.5% of the AP exam. It is the largest weighted section of all 10 units. So iteration comes up in the AP curriculum as Unit 4, okay? But it has the heaviest weighting at that high number. All right, so let's start by examining 4.1, the while loop. In the AP curriculum, this is described as represent iterative processes or processes using a while loop. For algorithms in the context of a particular specification that does not require the use of traversals, identify standard algorithms, modify standard algorithms, and develop an algorithm. We covered all this in Unit 1 of Computer Science 30S and technically in Computer Science 20S as well. Loops allow you to repeat one or more instructions over and over. They're another control structure that will flow and control program flow and control the code itself. Your preferences and the type of problem you're solving will determine how many times the loop will execute and what type or form that loop will take. We've already seen this structure in just general logic in things like flowcharts, where you can see a condition can cause an action, and that action may repeat until such time as the condition evaluates that the action does not need to repeat, creating a looping effect. So loops, like if or conditional statements, will evaluate to true or false in a Boolean condition. It is the body of the loop that will change that condition that may or may not cause that loop to repeat another time or continue or perhaps enter into something called an infinite loop, which we don't want. It can occur in two different ways. There are the event control loops and the count control loops. Event loops are created when you don't know how many times you want a loop to go. It's controlled by a certain event occurring, not a specific count. A count control loop is based on a count value, some type of numerical value that will execute a specific number of times. The event control loop, as you can see here, could be something like reading data out of a file, which you don't know how many times that could occur, and the event of reaching the end of the file will cause the loop to end. Whereas a count control loop will set up a counting variable and then run and increment or decrement, or at least change the variable such that the specific count is reached in a certain way, and then move on. So the first loop, the event loop, is generally written as a while loop. While loops or event loops can come in two different forms. When you want the test at the top of the loop, which is the standard while loop, and when you want the test at the bottom of the loop, which is the do while loop format. And that's so that the body of the loop executes at least one time. Loops, like conditional statements, are evaluated with a Boolean expression, and like conditional statements, you can combine logic using logical operators such as and, or, and not. Here's a simple example of a while loop. In this case, it is being used for counting, but it is while the number is less than 5, it will increment the number, produce a dialog box output, and then continue. On the 6th time, the loop fails in terms of the number no longer being less than 5, and it moves to the block of code outside the loop itself. While loops begin with the while keyword, and then they have the round braces, the Boolean expression, and then they can contain curly brackets to define a block, or if the loop is only one line of code, it does not need the curly brackets to define the block. Like conditional statements, when a block is defined, the code will be indented, one tab space, although again, as it says there, if it is one line of code, you do not need the curly brackets, and you may even move the code up to the same line as the while statement itself. Now, the second form of the while loop, by adding the do keyword, changes the loop so that the body of the loop executes at least once, and then the test is done at the bottom of the loop. The second version of the while loop, the do while loop, also uses a semicolon in its structure. So you can see here that version of the do while loop. The keyword do, and then the curly brackets define the block, which is indented. Then at the bottom of the loop, we have the while statement and the Boolean expression, followed by a semicolon to terminate that expression itself. Infinite loops are loops that never reach the false condition. Therefore, they continually loop. They run infinitely. This can potentially be a logic error in your coding. There are times when we intentionally write an infinite loop, but in general, what you want to do is avoid these types of things in the logic of your programming. Here's an example of that. We have a negative number. Number is -1. While the number is less than 0 and -1 is less than 0, keep subtracting to that number. Well, that will never reach a condition that is not less than 0. So this would generate an infinite loop that would never be false. This would be a logic error. Use the loop that's appropriate to your circumstance. So whether you're writing a standard while loop or the do while loop form, it depends on the logic of the program that for which you're writing. Content back in the 30S course, you can find examples of a lot of this different style of code in there. And now let's move on to the next topic, 4.2, which is the for loop. Okay, so with the for loop, now with the for loop, the way the AP curriculum defines it is representing iterative processes using a for loop. So what does that mean? Well, the for loop repeats a set of code instructions a specific number of times. It will continue to execute that code until a variable reaches a counting value. Semicolons separate three parts of the for loop structure: the starting value, the ending value, and the change value. So we'll see this in a more structured example, but the general way a for loop can be thought of is, what do I start at, what do I end at, and what do I change by? And for loops are generally used for counting scenarios. Let's look at a more practical example. So here, the for loop creates the variable I, sets it to its starting value of 0. The second part, so after the semicolon, the loop will continue as long as the condition of I being less than 10 is true. Then the semicolon. And the final condition is, what do I change I by? In this case, I++ means I will have 1 added to it for each iteration of the loop. So after 0, it'll go to 1, and then to 2, etc. Okay? So here you can see that all explained. The variable I is an often used name in for loops. You can think of it for integer or index or even iteration. I is a very common variable name for for loops. It sets the starting value here to 0, and then it checks to make sure it's less than 10, and then it uses the ++ shorthand to increase it by 1 on each iteration of that for loop. Okay, so there it is again, the basic structure of the for loop. It is certainly less intuitive than the while loop. It is much more sort of engineering based and much more sort of takes practice to get used to the structure. But you can vary this for loop in lots of different ways as well. Here you can see a for loop that starts at 10, keeps going to 100, and goes up by 10s each time rather than by 1. So you can see that for loop runs in a different format based on just some mathematical and logical structuring to position it that way. Okay? Here you see a for loop that starts at 5 and keeps going until it reaches 0, or a number greater than 0, and the variable decreases each time through the loop. So this would be a count down loop, a loop that iterates down instead of up. And there are other ways you can vary the for loop by using different mathematical processes, things like multiplying or dividing, even modulus division and things like that, to create a looping structure. Now I'll just finish this section up by saying loops, like if statements, can also be nested. You can have loops within loops to create more complex logical structures. We saw all of this in our example back in the 30S course and somewhat in the 20S course. So let's move on to topic 4.3, developing standard algorithms using strings. So how this is put into the curriculum in section 4.3 is that you would have algorithms in the context of specific or particular specification that involves the string object to identify standard algorithms, to modify standard algorithms, and to develop an algorithm. All right, so let's look at the string. The string is built into the Java language. It is a complex data type comparatively to the integer or the double. That's why string uses a capital S when it's declared. It can hold a string of characters or characters strung together. And strings, as a class type variable, have a lot of built-in functions that they can operate upon them. Join strings together or concatenate strings together using the addition operator or the plus sign. It does not actually add them like a mathematical operation, but it will concatenate or join the strings together. So let's take a look at an example of that. Here you can see 3 strings named title, first name, and last name. And then those 3 strings are concatenated together. Title plus first name plus last name concatenates them all together to create a string called full name. Okay? So strings join together using that operator. Converting strings to numerical types would involve a method known as parsing. So here you can see an example of that in Java code, where we're taking the integer class and parsing age, which is a string, into an integer called age value. Here's another example of parsing into both an integer and a float. You can parse into doubles and other numerical data types. Here you can see the character variable being pulled out of the string using the built-in method char_at. Here you also see built-in methods like length of a string and equals as it applies to strings. Strings have lots of built-in methods or functions built into them that you can explore in general, and you can see through the various examples that we did throughout our coursework in both the 20 and the 30S course when dealing with both strings and with looping. All right, moving on to topic 4.4, nested iteration. So the way the AP describes this is representing nested iterative processes, or essentially placing a loop inside the body of another loop, or the block of another loop. Okay? You as a student doing the AP exam should be familiar with questions that would nest loops inside of loops and being able to trace through those values to sort of see what kind of question result would turn out in something like a multiple choice question. So here's one example, not a great example, but you can see here a while loop with a for loop embedded inside its body, and inside the for loop, a do while loop embedded inside of that body. So we have 3 levels of nested looping there. Okay, moving on to section 4.5, the informal code analysis. Here's the way the AP describes that. Compute statement execution counts and informal runtime comparison of iterative statements. Those are just fancy words for be prepared for exam questions where you would have to trace the loop and figure out what the resulting output or changes the loop would make would do. So you can look back into many different examples of this throughout the 20S, the 30S, and even the 40S course, and should practice different examples of this so you can get a formal sort of look at how this type of thing can be done in things like exam questions. All right, let's summarize this section on iteration. So having studied this in the AP curriculum, having seen the snippet from the AP curriculum and broken down the vocabulary and stuff like that in the AP curriculum, we covered the while loop, the for loop, developing algorithms using strings, nested iteration, and informal code analysis. Now let's take a look at an example AP exam question that would be covering this type of content. All right, so let me move this out of the way and zoom in on this question for you guys. All right, so it says, consider the following code segment. It creates two integers, val and div. Then it writes a loop while val mod 2 equals 0 and div is greater than 0. And then inside the loop is an if statement. And then it gives you options A, B, C, D, and E for what the output would be in this case. All right, so let's break down this question. How could it go? Well, the while loop is contingent on both two different values. That's why the and is in place. Both have to be true. So the first condition, we mod, divide the value val by 2, okay? And since 48 divided by 2 is modding, okay, it examines the remainder of that division with a modulus. And does it equal 0? Well, val will divide evenly by 2. So yes, the first value will evaluate to true. The first condition is met. The second condition, div, okay, is just checking if div is greater than 0 and 6 is greater than 0. So it meets the conditions of the loop and it will enter the loop. Now it will hit the if statement, okay? Now 48 divided by 2 is 24, no remainder. Okay, we already said that. The if statement now mods val and div together. It takes 48, divides it by 6, and checks if there is a remainder to that, because that's what modulus division does. Well, 48 divided by 6 is 8 with no remainder, or a remainder of 0, so it will do the first output. It will output val at this point, and at this point val is 48. Now we'll move past the if statement, and it will take val, 48, and divide it by 2. So 48 divided by 2 will give us 24, okay? And div will subtract 1. So now div, which was 6, will become 5. Back to the top of the loop. Does it meet the conditions? Well, 48 is now 24. 24 divided by 2 does divide evenly, so that condition's made. And 5 is still greater than 0, so that condition's made, so the loop continues. Now let's check the if statement. Well, the if statement, if val divided by div. So now we're checking if 24 divided by div, which is 5, is an even division. Anyways, you can read through this. In the end, if you go through this, to me, the correct answer I got was A. That A is the correct answer for this problem. But you want to kind of examine this problem and go through it in detail, maybe even write the code out to see if this in fact produces those outputs as expected, to really practice that type of question so you can get it kind of finalized there. All right. That's the end of my presentation part of this. I'm just going to jump over now and take a look. One more sort of section here to look at. Just to wrap this up, what is a loop? A loop is like an if statement, okay? That is set, it's like a condition, it uses a condition to determine if code runs, but it runs over and over in a loop. So the loop tests for true or false. It creates a block of code, which are one or more lines, and can run itself over and over again. There's two types of loops, the deterministic versus the non-deterministic, or the count versus the event loop. The count is more generally the for loop, and the event is more generally the while loop. For loops like conditional statements. Well, here you can see a comparison between the structure of an if statement versus the structure of a while versus the structure of a for. Now, these are just code snippets. They're not incomplete, but you can see all of them use both curly brackets to define blocks, round brackets to contain the Boolean expression, and then the keywords if, while, and for. So here's a more practical example of a while loop. Well, count is less than 5, where we have one item compared with another item, and then define the block. Here we see that variation of the do while loop. right? Where you want the code to run at least once. Here you see a definition of the problem with the infinite loop, a loop that never stops looping because of probably a logic error in its construction. Here you see the basic breakdown of the for loop with a start, an end, and a change value. Here you see variations on the way a for loop can be laid out. Here's a general sort of review of all the main points of looping as I've outlined them there for you, so you can see there. And then finally, here is how the content is expressed in the AP curriculum and the vocabulary you want to be comfortable with. So I've already read you those learning objectives. Represent iterative processes using a while loop. For algorithms in the context of a particular specification that does not require the use of traversals, identify standard algorithms, modify standard algorithms, and develop an algorithm. Represent iterative processes using a for loop, and represent nested iterative processes. And the vocabulary you want to be comfortable with: the word iteration, loop, traversal, infinite, return, initialize, while, do, and for, the one-off error, the string, and the substring as part of what came up in the content of this unit. Well, that represents my quick review of this section of the AP curriculum on iteration. Have a great day, everybody. We'll see you in the next time.